So students, we want to look at, for an alternating series, we can determine whether the series is absolutely or conditionally convergent. So the idea here is that a series, let me just write it this way, is absolutely convergent if the absolute value of the series terms so let me just write the absolute value of a sub n is convergent. So you can have an alternating series. Let's just say this a sub n has -1 to the n of a sub n. And if you find that that series is absolutely you find that it's convergent, let's say you do the alternating series test and you find that it's convergent, if the absolute value of that test is also convergent, meaning you would have to show with a test of positive values like a limit comparison test. If you show that that series is also convergent, then your alternating series here you can say is absolutely convergent. Otherwise, the series is conditionally convergent. So an example of that is, let's say we have the series from n equals 1 to infinity of -1 over n, or -1 to the n over n. So this is the alternating harmonic series. And we know that that is convergent. And we can show that that's convergent using the alternating series test. So if we do the alternating series test, we can say that 1 over n plus 1 is less than or equal to 1 over n. And the limit as n goes to infinity of 1 over n is equal to 0. So that means that that series is convergent. However, we also know that the series n equals 1 to infinity of 1 over n, which would be the absolute value of the alternating series, is a divergent p-series. So since the absolute value of this series here is divergent, we would say that the alternating harmonic series is conditionally convergent. Now our last two tests that we're going to look at are going to be the ratio and the root tests. And the good thing about these tests is that because the test involves the absolute value, the test itself will tell you whether it's absolutely convergent or not. And so I'll do that in the second video.